Why do atoms combine? Let us learn about this in detail. And why only certain atoms or atoms of certain elements only combine? Why the atoms of gases like helium, neon, etc. do not combine? So for all these questions, let us try to find the answers now. So we learned the electronic configurations in the chapter structure of atom. So electronic configuration. Electronic configuration is the arrangement of electrons, arrangement of electrons in different shells or subshells, different shells around the nucleus, around the nucleus. For example, atomic number of hydrogen is 1, it has only one electron, therefore 1s1, and its electron picture is like this. Or hydrogen, we can write in this manner also, one electron in K shell. Similarly, helium, atomic number 2, electronic configuration 1s2, so 2 electrons are here. And or helium with atomic number 2, 2 electrons in K shell. On the other hand, lithium with atomic number 7, so configuration 1s2, 2s1. So outermost shell is S subshell, that is second level S subshell. Therefore, the valence shell, outermost shell is also referred as valence shell. Valence shell has only one electron. Or in different way, lithium, 2 electrons and 1 electron here. K shell, L shell. Next element is beryllium. Beryllium with atomic number 4, mass number 9, configuration 1s2, 2s2. So electrons present in outermost shell is 2 electrons, or beryllium 4, 9, and we get 2, 2. This is K shell, this is L shell. In structure of atom, we studied that there are different shells, there are shells around the nucleus, around the nucleus. These are electronic shells. So the number of electrons in these shells will be 2n square, where n is the number of shell. Thus K shell means n is 1. So 2 into 1 square equal to 2 electrons. So K shell can accommodate only 2 electrons. L shell, L is the second shell, 2 into 2 square equal to 8. M shell, M is the third shell, 2 into 3 square is equal to 18. Similarly, N shell, 2 into 4 square, N is 4, this is 16, 32 electrons. So thus the first, second, third and fourth shells, they accommodate a maximum of 2 electrons, 8 electrons, 18 electrons and 32 electrons. Thus the first shell has 2 electrons, therefore electrons enter into the next shell. Beryllium has only 2 electrons in the second shell, still it accommodates 6 more electrons. Next element is boron. Boron with atomic number 5, mass number 9. So 1s2, 2s2, 2p1. Electron picture for outermost shell, 2 electrons, and here in p subshell there are 3 orbitals. 3 orbitals can accommodate, and of course since there is only one electron, that electron enters into p subshell. Boron in a KLMN method also it can be represented B59, 2 electrons in K shell, 3 electrons in L shell. So outermost electrons can be shown as dots. So outer electrons Outer electrons means valence electrons. Outer electrons can be shown as dots. A scientist Louis proposed this. So Louis proposed the dot picture. Louis proposed the dot picture. So boron, only for a Lewis structure, only outermost electrons should be shown. Outermost shell has 3 electrons here. So 1 electron here, 1 electron here, 1 electron here. Boron has 3 electrons in outermost shell. Similarly, carbon C6 2 4 2 4. Let us write the few elements initially. Nitrogen 7 14, carbon 6 12, oxygen 8 16, and neon 10 20. So here the configuration is 2 5. Here the configuration is 2 6, and now here fluorine 9 19. So for these elements, let us write the electronic configuration. So carbon has 6 electrons, 4 electrons in outermost shell, 1 2 3 4. So this is Lewis structure. Lewis structure for carbon. For nitrogen, 5 electrons are there. So on 4 sides you keep 4 electrons, and one pair is here. Similarly, for oxygen, 6 electrons are there. 1, 2, 3, 4. Out of 6, 4 are accommodated already. Therefore, this is the 5th electron. This is the 6th electron. Similarly, for fluorine, 2, 7. 7 electrons are there in outermost shell. Therefore, this is F. 7 electrons in outermost shell. 1, 2, 3, 4. 5th one, 6th one, and 7th one. So there are 7 electrons in the outermost shell of the fluorine. Neon. Neon with atomic number 10, mass number 20. So configuration 1s2, 2s2, 2p6. So here 8 electrons are there in outermost shell. Or it can also be written as 2, 8, K shell, N shell. So atoms having atoms with 8 electrons, 8 electrons in their outer shell are said to be with octet completed. Octet completed. Octet means 8 electrons. Having 8 electrons in the outermost shell is referred as octet. So neon completes its octet. So other inert gases. Inert gases means those who do not react with other substances. So since they are in gaseous state, they are referred as inert gases. Helium with atomic number 2, neon 10, argon 18. So 2 electrons, 2 8 electrons, 2 8 8 electrons. So they have 8 electrons in the outermost shell, therefore octet is completed. And helium is a special case having a duplet configuration. Duplet means 2. Okay. So next element is krypton. Krypton. Krypton with atomic number. Next element is krypton, Kr. 36, xenon 54, and radon 86. So here configuration is 2, 8, 18, 8, 2, 8, 18, 8, 2, 8, 18, 18, 8. And here this is 2, 8, 18, 32, 18, and this is 18, 18, 8. So in all these inert gases, the outermost shell has 8 electrons, therefore their octet is completed and they do not react with other substances. Then what is the relation between non-reactivity and electronic configuration? So therefore atoms with octet configuration, atoms with octet configuration, that is 8 electrons in the outermost shell, are least energetic, least energetic and highly stable. Highly stable means they do not react with, they do not react with other elements. They do not react with other elements. Then what about other elements? Those elements which do not have octet configuration. Therefore, elements with less than 8 electrons. Keep the point in mind, any element, any atom does not have more than 8 electrons in the outermost shell. Therefore, elements or atoms with less than 8 electrons in valence shell are highly energetic and less highly energetic and less stable, less stable. Therefore, they react with other substances. Therefore, they react with other substances. They react with other substances. Here, neon, argon, krypton, xenon, radon, they are referred as inert gases. Inert gases. They have octet configuration. Since they have octet configuration, their inert gases means do not combine with others. Do not combine with others. Why they do not combine with others? Because they have least energy. They have least energy. So atoms with least energy do not combine with others. So from this we can conclude that atoms with least energy do not combine with others. Do not combine with others. So this is the relation between energy of the atom and its chemical nature or chemical reactivity. So in the previous table we have seen that nitrogen, phosphorus, arsenic, stibinum, bismuth. Nitrogen atomic number 7, phosphorus 15. So here configuration 2, 5. So it needs 3 electrons to complete its octet. Needs 2 electrons to complete its octet. Similarly, in all this group, the elements need 3 electrons. Therefore, this is a 15th group. So 15th group elements need 3 electrons to complete their octet. So if nitrogen takes 3 electrons, nitrogen 7, if it takes 3 electrons, then it becomes how many protons here? 7 protons and 7 electrons. originally, therefore charge is neutral. Therefore, when nitrogen takes 3 electrons, it becomes 7 protons and 10 electrons. Therefore, 10 electrons minus 10. Therefore, the charge becomes minus 3. Therefore, this becomes N3 minus. So, this is a tri-negative ion. Tri-negative ion. Tri-negative ion. On the other hand, oxygen, sulfur, selenium, tellurium, polonium. Atomic numbers 8, 16, 34, 34, 8, 16, 34 atomic numbers. So configuration 2, 6, 2, 6. This is 2, 8, 6. So valence shell has 6 electrons. Therefore, they need 2 more electrons to complete octet. 2 more electrons to complete octet. So if they take 2 electrons, so oxygen 8 electrons plus if it takes 2 electrons, then what happens here? 8 electrons, 8 protons and 8 electrons, therefore the charge is 0. Whereas here after taking 2 electrons, O8, protons are 8 only, but electrons become 10. Therefore, plus 8 minus 10 equal to minus 2 units of charge. So this is 2 minus. Therefore, when this group elements, oxygen family, take 2 electrons, they become di-negative ions. They become di-negative ions. Therefore, their valency is minus 2. Their valence is minus 2 means they attract 2 electrons and gain 2 units of negative charge. On the other hand, halogens. Halogens means halo means salt. Gen means form. Salt formers. Halogens means salt formers. Fluorine, chlorine, bromine, iodine, astatine. This is astatine. This is iodine, bromine. Right, 9, 17, 35, 53. This is 85. So here 2 electrons, 7 electrons. Therefore, needs 1 electron. They need 1 electron to get octet. So if they get 2 electrons, they become uni-negative ions. Uni-negative ions. Therefore, their valence is minus 1. Their valence is minus 1. On the other hand, on the table we have seen first group elements. What do you call first group elements? Alkali metals. Alkali means bases. Bases means turn red litmus to blue. Therefore, lithium, sodium, potassium, rubidium, cesium, francium. So lithium atomic number 3, 11, 19, 37, 55, 87. So here 21, 281, this is 28881. Therefore, these elements readily lose 1 electron. Readily lose 1 electron. And become uni-negative ions. uninegative ions. Therefore, their valency of alkali metals. Valency is +1. Their valency is +1. Similarly, alkali earth metals. Alkali earth metals. What are the alkali earth metals? Beryllium, magnesium, calcium, strontium, barium, and radium. So 2, 12, 20, 38, 54, 86. So 2, 2, 2, 8, 2. Therefore, they lose 3 electrons. Sorry, 2 electrons. As they lose 2 electrons, they become dipositive ions. They become dipositive ions. As they become dipositive ions, their valency is +2. Therefore, alkali earth metals, they belong to second group. They belong to second group in the periodic table. Second group in the periodic table. Right. If you take, say, that 13th group, boron, boron symbol is B. 13th group, boron, aluminium, gallium, indium, thallium. 5, 13, 31, 47, 47. And this is okay. So configuration 2, 3, 2, 8, 3. Therefore, they have 3 electrons in their outer shell. 3 electrons in their outer shell. Therefore, they lose 3 electrons and form tri-negative ions. Now let us represent electron picture for all these. Previously, in the previous slide, I showed the electronic configurations up to some elements. Now electron picture for neon. Neon atomic number 10 with 2, 8. Outermost shell has 8 electrons. Therefore, neon. And these 8 electrons should be shown here. 2 electrons here, 2 electrons, 2 electrons, 2 electrons. Therefore, this is a neon electron picture. So, electron picture was introduced by Lewis. Therefore, this is also referred as a Lewis dot picture. For example, sodium. Let us take sodium. Sodium 11. So, what is the picture? Electron picture Na. It has 1 electron in outermost shell. Therefore, Na, it has only 1. Suppose if sodium loses this electron, then sodium becomes sodium plus. Sodium plus, as it lost its electron, then it has 8 electrons in the outermost shell. Therefore, Na, 2 electrons here, 2 electrons, 2 electrons, 2 electrons. Since sodium atom loses 1 electron, it gets 1 unit of positive charge. Therefore, this is sodium ion. On the other hand, if you take magnesium, say magnesium atomic number 12, so configuration 282. So therefore, magnesium, it has only 2 electrons in the outermost shell. Therefore, 2 electrons. This is dot picture. That is electron dot picture. If magnesium loses 2 electrons, so 2 electrons, as 2 electrons are lost, what happens? Magnesium gained 2 units of positive charge on it. Therefore, what is the electron picture for magnesium ion? Since 2 electrons are lost, this second shell becomes outermost shell. Therefore, 2 here, 2 here, 2 here, 2 here. Therefore, magnesium has 2 units of positive charge. Therefore, this is magnesium dipositive ion. Magnesium dipositive ion. Now let us take chlorine. Chlorine 17, configuration 287. So it has 7 electrons in the outermost shell. Therefore, electron picture for chlorine, 7 electrons should be there. 1, 2, 3, 4, 5, 6, 7 electrons. Right. If chlorine takes 1 electron, it takes 1 electron from outside. Therefore, how many electrons become? Sodium chlorine has 17 electrons plus 1 electron. Totally it has 8 electrons. Therefore, outermost shell has 8 electrons. So, for this the electron dot picture is electron dot picture Cl 1, 2, 3, 4, 4, 5, 6, 2, and this is 7th electron. And of course, I am showing this 8th electron with the color one as it came from outside just to make the differentiation. Since chlorine has 1 electron, 1 excess electron, chlorine has 1 unit of negative charge. Therefore, this we refer it as chlorine uni-negative ion. Uni-negative ion means it is anion. Anion.